Thanks for the intro first, and thanks everyone for being here to talk about gestures in JavaScript. So JStures, so funny. All right, so before I dive into the topic, I already got introduced, but here's, if you were not listening. I'm a developer advocate at Stripe. If you're not familiar with Stripe, we're a fintech company. We provide products from fraud detections for transactions or online identity verification. But we're probably most well known for being able to let you handle payments on your site easily. So we handle all the hard parts of payments, so you don't have to. And as a dev advocate there, I work on three main things. So as an advocate, the general role would be to create educational resources for people to learn how to use our products, but I'm also helping with maintaining our open source samples. So if you've ever used Stripe, you might know that we provide samples in 7 different languages, so that's a lot of maintenance. And maybe the most interesting part of my job is that I also get to do more general technological research, where I can pick a topic that I'm interested in, and I'm kind of asking myself a lot of what-if questions. And if it ends up being useful for Stripe, cool. But if not, that's cool too. So I feel very lucky to be able to do this, because that's something that I usually do on my own time, but now I get to be paid for it, so that's cool. And apart from that, yes, I'm part of the Google Developer Experts program. I'm an expert in web technologies, whatever that means. I'm the author of a book about machine learning in JavaScript. And overall, I like to, or I guess I identify more with the title of creative technologist, because I love to experiment and push the boundaries of what can be done with web technologies or with technologies in general. And hopefully, what I'm going to talk to you about today will give you an idea about that. All right, so I want to start talking more broadly about human-computer interactions. So in general, it's kind of shortened to HCI. And it's a subfield of technology that is related to the interaction between humans and computers in terms of inputs and outputs. So in your day-to-day, for example, when you're using a mouse, the input would be you dragging or clicking on the mouse, and the output is the icon moving on the screen and you being able to interact with an interface. But if you think about a keyboard, it's a different kind of input because you're typing on keys, and the output is also different. It's letters being displayed. We also have touch screens, joysticks, voice assistants, any way that you have some kind of interaction between a human and a computer. And it's something that as JavaScript developers or front-end developers in general, we don't really hack on that very often. Most of the time, we rely on standards that are already available, and we just use them through web APIs. So we didn't define that a mouse has to be dragged or clicked, but we use that kind of interaction through on-click events or on-mouse downs, etc. But it's not because we don't define these standards that we can't explore that space and experiment with other ways to interact with interfaces, and especially explore different kind of interactions. So if you spend some time imagining that the mouse and the keyboard didn't exist, how would you want to interact with interfaces or browse data, etc.? And an example of potentially innovative interaction is with motion detection. So if you think about just motion detection right now, in your day-to-day life, you might think of something like this. So like a standard motion detector that you might be able to buy in store. It turns lights, on or off, in your office or outside your house, or it could be like a security alarm system. But that's pretty much it. So what it detects is basically, is there movement or not? It doesn't know, or it doesn't detect specific movement. For example, it doesn't know if you're running, walking, jumping. It doesn't even know if the movement comes from a person, an object, or an animal. So we're not talking about cameras. We're talking about specifically just motion detectors. And if that's the kind of interaction that you want, just is there movement or not, you can build a standard motion detector device like that as a front-end developer. If you use an Arduino or a Raspberry Pi, for example, with a motion sensor like a small radar, or what is called the PIR sensor, you can get live data and customize your application in JavaScript. But using these two sensors that I mentioned, so the radar or the PIR sensor, they're just as standards as the one that you buy in store, meaning that they can detect some kind of motion, but that's it. However, movement is much more complex and interesting than is it just happening or not. You can have a lot of contextual information associated with a movement. For example, even if it's just the time of day or the location at which you're executing that movement. So if we take as an example, you have a sensor attached to your leg, for example, and you're just tracking yourself throughout the day, and you're exercising, and it happens that you usually exercise in the evening at the gym. So we have the time of the day is the evening, the location is the gym. And if you're doing that over time, you could have a system that learns, okay, if Charlie's like in the evening at the gym moving her legs like, you know, running, then I know that this is the activity that I'm doing. But if all of a sudden I'm outside in the morning, but still running, you could have a system that's like, oh, that doesn't look like the movement that you were doing before. And all of a sudden it could be me running after a bus or a taxi, for example. So there is extra information necessary to understand what I'm doing, even though the movement might be the same. But also the movement itself might be more complex than a kind of on or off stage. So for example, if I do a thumbs up, it would mean something to you that's different than if I'm waving my hand to say hi. Or if you're in a meeting and I raise my hand to speak, I do it in a different way than if I raise my hand to catch a bus. Like if you're sitting in a meeting and you want to speak, you're not going to be like, hey, like that's going to look a bit weird. I mean, you can do it if you want, but it usually would mean something different. So can we take advantage of the fact that movements are actually quite contextual and specific to build smarter and more customizable systems while still being only a front-end dev? I mean, only, I love front-end, like not only is it bad, but anyway. Well, the answer is yes, and obviously that's why I'm giving this talk today. So it's definitely possible, and even better, it's possible than less than 50 lines of code, or even if you remove some bits that you're not going to need, it could even be less than 15 lines of code. So the first step is to use a microcontroller that has a built-in accelerometer and gyroscope. So the one that I'm using is called the Arduino 33 Nano BLE board. BLE Sense, actually. So that's a super long name, but there's a lot of different models of Arduino that are available. So if you want to reproduce what I'm going to show you in this talk, it's going to be easier if you use that board. So there is a similar model that's called the Arduino Nano 33 IoT board, but that one uses connection over Wi-Fi, and for what I'm going to show you today, we need the board to be connected to the browser via Bluetooth. So if you want to work with that, make sure to buy the BLE one, so Bluetooth Low Energy. So this board is super small, like I have it here. Probably the first row will be able to see it, but at the back, well anyway, it's like the size of my thumb. And it's about $40 US. I think with like the chip shortage at the moment, it's sold out on a lot of different websites. So if you have one right now, you're lucky. If not, you might have to wait a little bit if you want to buy one. And so the reason why you would need a board with an accelerometer and a gyroscope is because you get 3 points of data, so x, y, and z, for the coordinates of your movement for acceleration, so how fast you're moving, and for your rotation, so with the gyroscope. So you get x, y, and z coordinates for both acceleration and rotation, multiple times per second, which actually gives you quite a lot of data to be able to differentiate between different movements. Okay, so that's for the hardware part of this project. But how do you actually get the data and do something with it? So for the software part, we're going to do some machine learning using TensorFlow.js and Arduino. So if you've never tinkered with Arduino, it's fine, because all you need to do is upload a pre-written sketch that is open source. So a sketch is how programs are called when you upload them to Arduino. You don't have to write any C code if you don't want to. And why is machine learning involved? Because the board is going to gather live data about my movements and try to predict a gesture executed based on some training data that I'm going to record. So by default, when you plug the Arduino to your computer, it's not quite ready to handle a machine learning model. It doesn't have that built-in logic. So to make it work, we upload a pre-written sketch to the board, and it adds the logic to communicate to the browser via Bluetooth, and it also receives the machine learning model from the browser and runs it with live motion data. So that part is in C, but in JavaScript then, what can we do? Well, we can do everything else. So what that means is we can use the Web Bluetooth API to connect to the Arduino and receive data. we can process that data. And what that means is that the live data that you get from the Arduino will be like an array of integers. And that's not the format that TensorFlow can work with. TensorFlow works with tensors. So you have to go from your array of integers, process it in a way that you like, and then transform it into tensors, and then feed that to TensorFlow.js. And then with TensorFlow.js, you can create a machine learning model, train it, test it, export it. So you can do like all of these steps from scratch on your own in JavaScript, or you can also use a project built by Google Creative Lab called Tiny Motion Trainer. So it allows you to do all of the steps that I just mentioned. So recording data, connecting to the board, creating machine learning model, train it, export it, blah, blah, blah. But in just a few minutes via a UI. So I'm going to try to show you quickly how it works if my setup is going to be working fine. So if I move my mouse and yeah, OK. So if I connect the board, so I'm only connected to my computer because that's how I'm powering the Arduino. Usually you would want to power it with an external battery. I had one that I tried this morning, but it kind of killed the board a few times, so I just thought it wasn't a good idea. So I'm powering it with the computer, which would be fine. It just means that it's going to look like it needs to be wired in, but it's only for power. It's not for transmission of any data. OK, so I'm on Tiny Motion Trainer. I'm going to start a new project. And first, it needs to connect to the board, because at the moment, again, it's just powering it, but it's not actually connecting. So I'm going to connect, and I should be seeing my board. Yes, whew, I got scared for a second. OK, so, and if it works, OK, so I see the little like jiggle jiggle, so it means I'm connected. I'll talk about the settings a bit later, but for now, don't worry about it. So it means like you know you're connected if it means you move, and it moves. Cool, we're moving. So then capturing data. So we're going to pick 2 gestures. So I'm going to start with a simple wave, so that you add a label to be able to kind of recognize it later on. So I create my new gesture, and then I click on it. I'm going to hold my board. I'm going to start recording. I'm just waving. I'm just waving. I'm going to stop at like 10. Yeah, OK, or 11, whatever. And then I'm going to start to train my second gesture. So I'm going to do like a swipe. I don't know how you call the like money, money, bills, bills. So I'm going to call it swipe. So I'm going to go to this one. I'm going to start like swipe, money, money, bills, bills, stripe, so much money. OK, so I have my 2 gestures. And what's going on here is that, so you have the visual representation of the data coming from the Arduino, but as a graph. So what's awesome is that if you can see the difference between the 2 gestures visually, well, there's not that much. Yeah, you can see it. It means that for a machine learning model, you can be pretty confident that it's going to find these patterns. If you find gestures that are very similar, you might want to record more of them or change some of the settings, so you can kind of play around. But we're going to move on and train my model. And all I need to do is click Start Training. And it's just training it live in the browser, machine learning. And what's going on here, it gives you the graphs about the accuracy. So it's using all the samples I just recorded. And it kind of gives you an output. So usually accuracy, you don't want it to be 1, because it means it's like overfitting. I'm not going to go into that. But it's as close to 1 as possible, the better. And the loss is like how many times it's comparing the test set to the training set and seeing it if there's any issue. So that's it. Like in a few seconds, I trained my model, and here we're testing it. So I have my 2 gestures, wave and swipe. So if I wave, woohoo, OK. And if I swipe, yeah, wave, swipe, wave. And you can have fun like that for a while. But anyway, so you can be sure that it's pretty accurate. It's like, OK, I'm moving. It's doing the thing. And then the last step, I'm not going to do it here, but you can download your model. So it means like in not even 2 minutes, I picked some labels of gestures, I recorded a few samples, trained it, tested it, and I can export it. But I'm going to just refresh that because I needed something for later. OK, if I go back to, cool, we're back. So if you are interested in understanding more how this project is built in the background, it is actually open source, which is awesome. So you can dive a little bit deeper and understand how it all works, but I don't have the time for that right now. So we've trained our model with our different gestures. How do we actually use that then to add gesture control in a web app? So the awesome team at Google Creative Lab also provided a JavaScript snippet that you can use to quickly and easily load and transfer your model from the browser to the Arduino to get the predicted gestures back to the UI after. So you might be wondering, how does it all work? What does this do? So again, this script is about 1,000 lines of code, so I can't dive into the whole thing. But to understand better what it does, I did spend some time kind of like diving into the source code and recreating my own version, a bit more like simplified. And you can build something similar in about 350 lines of code. But at core, the two main things that it does is that it handles the communication with the Arduino in JavaScript. So we're in Bluetooth, so the sketch that is uploaded on the Arduino sets up unique services and characteristics. So kind of like it's going to hold values about certain features. For example, the transfer state, like is the model being transferred or has it finished transferring? Or the number of samples that were recorded. So things like that are going to hold values on the Arduino. And the JavaScript part is going to just use the same unique IDs to make sure that it communicates and writes values to the right properties. So that's the first thing that this script does. And second, it splits the machine learning model into chunks and just transfers that via Bluetooth to the Arduino and checks that it does a checksum to make sure that what the Arduino has received is the same thing that was sent by the browser. And it kind of puts it all back together and runs it, which is really cool. And at first, when I experimented with that project, I was like, whoa, how does it all transfer it via Bluetooth? Like, woo. And when you read the source code and you realize, oh, it's just a file. So it just splits it into chunks, sends them all at once until the entire file is sent, and then runs it on the Arduino. I mean, I make it sound like it's easy. It's probably a lot of work. But it's nice to be able to look at source code and realize that, oh, actually, it's like nice to, it's not that magical anymore. It's still fun, but anyway. So adding this script to your app will make available an object on the window that is called TinyML Experiment BLE Interface. So again, long name, but at least you can be sure that it's not going to conflict with anything else that is accessible on the window object. And you can pass in different parameters for your model and get the gestures detected. So first, it creates a button on the page to connect to the Arduino device. So the reason why it does that is because when you work with the Web Bluetooth API, you need a gesture or an action from the user to start the connection to the device. So for security reasons, you don't want your browser to automatically connect to whatever Bluetooth device is nearby and available. So usually we use a button, like a click on a button, but you could use any kind of gesture that means that the connection is intentional from the user. So start by creating that button, and then you can pass an object with the model's parameters. So first, the path to the file. So when I showed you that the last step on Tiny Motion Trainer where you export the file and you have to add it in your app, I didn't do it there because the demos I'm going to show you, I already have a model. And yeah, so you might notice that the TF-Lite file extension, so it's a specific extension for machine learning models that are meant to be run on low memory devices. So perfect for microcontrollers and IoT stuff. And one awesome thing about these files, well, they're called TF-Lite because they're light. And a custom model with 2 gestures is about, I think mine was about 8 kilobytes, which if you compare to other models, if you have worked with machine learning before, especially around, for example, object detection, a lot more like visual kind of models that are fed with images, they're a lot bigger than 8 kilobytes. So if you are building a web app, you could kind of see the impact in terms of performance. But 8 kilobytes, I mean, I'm pretty sure it's probably lighter than React. I mean, I don't know. Don't quote me on this. I didn't check. But it sounds pretty light. So for a machine learning model that can detect gestures live, like, I'm super impressed. So then we have to indicate the number of classes. And that's the gestures that we trained. Here I indicated 2 because I trained 2 gestures. But if you train 3, you write 3. You got it. So then the threshold is a value between 0 and 1 that represents the threshold at which the model will start to classify a certain gesture. So it doesn't try to detect macro gestures. So if I move my arm slightly, I don't want the whole logic to run because I'm not actually executing any gesture. So the closer to 0, the more sensitive it's going to be. And the closer to 1, you'll have to be more intentional. Then the number of samples represent the number of samples recorded per second. So these settings that I'm talking about, they have to be the same as the one that were on the first step of Tiny Motion Trainer. You have to use these same values because the model was trained with these settings. So when you actually use the model, you also need to use the same settings. The capture delay is the delay between samples of data used to recognize the gesture. So the closer to 0, the faster it's going to look at new live data to predict a new gesture. And the closer to 1, the slower it's going to be. And then you have a few different events available, such as on connect. So if you want to show a message in your UI when the board is connected to the browser, you have on transfer progress if you want to show a progress bar as the model is uploaded to the board. On disconnect if you want to kind of have an alert so that the user doesn't think the board is connected if it's not. And more importantly, you have on inference. And what this function does, it executes when the code on the Arduino has predicted a new gesture in live data and notifies the front end. So we can then access the index property on that object, and represents the index of the gesture trained. So my first gesture would be index 0, second gesture index 1, etc. And based on that index, you can trigger any kind of front-end code you want. Here I put like console log, that's boring. But you can imagine your app where you would have, you can really make it do whatever you want. So for example, you could, I could scroll down when I swipe, or I could play a video, or pause a video, or I don't know, whatever. So whatever you can think of. My favorite part, though, is that it really abstracts the complexity of building a gesture recognition system so that you can focus on actually building your app, thinking about your interactions, and having fun with that. OK, so just to recap the steps to get it to work. So you have to start by uploading the sketch to the board. I didn't show that part because it's really clicking on a few buttons. I thought it wasn't really relevant. Then you train your model in Tiny Motion Trainer in a few minutes or less. You export the model, you put it in your app folder. And then you import the script that's called Tiny for Micromotion Kit, and you write some JavaScript to add some interactions. So in like 3 steps, that should take you a few minutes, hopefully, you can have something that works. But well, to show you an example of what you can build with it, I have one demo, and then I'm going to talk about a few other. I'm going to try another one, but we'll see what. Yeah, I have time. OK, so my first example is something that I built 3 to 4 years ago, and I called it Air Street Fighter. Very creative, it's just Air Street Fighter. It didn't use, so my first version didn't use the Arduino Nano 33 BLE Sense or Tiny Motion Trainer because it didn't exist at the time. So I built the first version with everything from scratch using TensorFlow.js. So it still used an Arduino, just a different model. I had different, like separate sensors that I put together into a circuit. And I did the whole steps that I told you at the beginning of connecting to the board, collecting data, building a machine learning version, like blah, blah, blah. Yeah, you'll remember the steps if you listen to me. So I just like keep repeating myself. So it was super interesting to build. I feel like I studied the other way. I studied like the hard way, and then I found Tiny Motion Trainer that made it easy, and I kept going the easy way. But basically, I trained 3 different gestures to control a character. And I'm going to try to demo it. If I can go back to the screen, and if I do this, and if I switch tab. What are my tabs? This one? Yes. OK. OK, so this is connected. Just going to disconnect just to try. All right, so well, the font is a bit small, but don't worry about it. It's not about reading. So I'm going to connect it. Again, I have to select it. Yes. All right. And now it should be uploading. I was like, OK. So it is uploading via Bluetooth the model to the board right now, which is like super cool. I wish I could really show you so I could like detach from the laptop and do it from there. But next time I'll use a battery pack. All right, so we're ready. So I'm holding the board. Start. So I'm, well, with the resizing. OK, so I'm like the red one. Actually, I'm going to do it here. All right. So if I do. Oh, well, the sound is on my laptop, but imagine some sound. So I don't know if I can put it louder. You're probably not going to hear it. OK, so if I do like, yay, and if I do, yay, OK, if I do that, no, OK, the third one, I want the big one. No, not that one. Yeah, that one. OK, sorry. So OK. So obviously it is a prototype because the other character is not even moving. But you can imagine how you could hook up, because the browser can connect to multiple Arduinos. So you could imagine that you would have a friend that plays the second character, and if you also had an Arduino on your legs, then you could be like moving like this, and it would make the character move. I didn't really go further in that prototype because all I wanted to confirm is that would it work, and it did. So then I just moved on. But yeah. And the interesting thing as well is that, let me just, OK, I'll move on to the, yeah. OK, so the first time that I created this project, I actually wrote 3 different versions of it. So I wrote one with an Arduino Maker 1000 and two different sensors. But as it basically needs a gyroscope and accelerometer, you can build the same kind of projects with a lot of different devices. I also used a Daydream controller, which was something that worked with a Google VR device, and then they updated the firmware, it doesn't work anymore. But what you might all have in your pockets is a phone. And with JavaScript, you can use the generic sensor web API that also gives you access to a gyroscope and microphone. And you can build the exact same thing where instead of having to hold an Arduino, you would hold your phone, and you would just do that. And it works. I forgot where I put the code, but somewhere. Probably on GitHub. Yeah. So, so if you wanted to experiment with this, but you don't want to buy an Arduino, you can, get data from your phone in JavaScript and play around with TensorFlow. So it wouldn't work with Tiny Motion Trainer, because that's really a platform just for the Arduino. But it means that if you want to dive deeper, you can kind of look at the source code and maybe try to pick what you think would be helpful. But maybe you're not into games, maybe you prefer music. So around the same time that I built my first version of Air Street Fighter, I also worked on building some kind of air drums project. So this does not use custom-made hardware. So this version on the GIF here is not made with Arduino. It's actually devices that are called free drums that you could buy online. I don't know if you still can. But the concept is the same. So inside the hardware, there's accelerometer and gyroscope as well. And at the time, the only way that you could interact with this was with an application that you had to download. And I don't want to do that. So I created a JavaScript framework called Nordic.js, again, very creative. And it gets data from the movement of these sensors, and you can trigger lights and music. Because once you get data, the rest is really up to you. So I didn't recreate this with Arduino, but it's something that hopefully you can imagine is possible. And actually, some people have done exactly that. So with the Arduino that I have here, there's an experiment called Air Snare. So if you already have an Arduino Nano 33 BLE. By the end of this talk, you should know the name. So if you have it, you can check out this experiment and kind of play, air drums on it. So an interesting thing to notice is that, even though that project is not mine, I can actually use it without having to retrain the model. So you just connect and move it the way that they ask you to move it, and it works. So it means that if you were building an application with this, you don't have to force your user to retrain a model. If it's a gesture that's pretty standard between different people, it would just work. But then maybe you're not into games, maybe you're not into music, maybe you're into fitness. So I'm definitely not going to demo that one, but the Arduino isn't attached to a hand, you're not holding it, it's attached to a leg, so you could detect what, a squat is and make your own fitness app, or, you could and not unlock your phone until you do 50 squats, if that's what you like to do. But otherwise, it kind of reminded me of something called Ring Fit Adventure. If you have a Nintendo Switch, I actually love Ring Fit Adventure. So, and it's if you don't have it, it's on the Switch, so you use the joysticks, and there's one that you attach to your leg, and then you do kind of exercises, and it's like a game. And the concept is the same as well. The joystick on a Nintendo Switch have an accelerometer and a gyroscope, and you could recreate your own version if you wanted to. It doesn't even have to be about body movements. You could track your own movement of IoT appliances. So the way that your washing machine moves, there's different cycles, and the way that it moves would be different. And actually, I was at Cascadia.js a few weeks ago, and there was a talk by a couple who talked about how they automated their relationship so they wouldn't fight over who's doing chores. And I thought that you could actually have an Arduino attached to a washing machine, learn about the different cycles based on how it vibrates, and then that works offline, because if you download the model and run your app with all your files locally, you don't need to be connected to the internet. You just transmit notifications via Bluetooth. You could make that work in a Chrome extension. You can trigger any kind of IoT devices that you want. And more recently, I started kind of thinking about okay, so I'm having fun with this, but could it be related to something that could be useful for Stripe? And actually, I started looking at gesture-based payments. So maybe you're like, no. I'm like, yeah. So, so I did a bit of research, and so this is not mine, but actually I stumbled upon the fact that there are patents for that already. So if you look at it as a payment method, you could have a gesture module on a credit card, so to kind of have a two-step payment method. So you would pay with the card, you'd have to tap the card because there's details that need to be sent, but you could kind of confirm the payment by doing a custom gesture that has been trained by a user. And if I can show you one last thing, I kind of tried to build it. Oh, well, it's gone. So, actually, is it? Wait. Boop. Is it? It doesn't want to. Well, I guess you won't get to see it. So it's just, I tried to build a little demo. I'll be sharing it next week, so on Twitter if you want to have a look. But anyway, on this, thank you so much. Hopefully you learned something in this talk. I'm not done. So are you telling me that you want me to shut up? Is that the thing? Anyway, all I wanted to say to finish is that yesterday Sarah talked about how you can do Blender and 3D on the web pretty easily, and I hope that this talk kind of showed you that machine learning is also something that you can start doing. It doesn't have to be complicated. You can start easy and then dive a bit deeper if you want. Anyway, this time I'm going to shut up. Thank you so much.